Okay, this is number 18 from the review. This is just like 17 in terms of the directions. It's just asking to find the integral of this vector field over the contour, which is the line segment connecting those two points. In this case, you don't have to really graph these things accurately. Just to get an idea of what's going on, I have one point, I have another point, and I'm traveling between them. I'm going to call this P and this Q. And the directions say to use the fundamental theorem. So what I'm supposed to do is I'm supposed to think that this vector field is the gradient of something. And so what I need to do is find that function, and all I need to do is plug in the endpoints of the contour. So just like before, what's different in this case is that we have a three-dimensional vector field, and so finding this f is going to be a little bit more work. Okay, let's write down what all these things are. So if this is a vector field, and what I'm hoping is that it's the vector field that comes from taking the gradient of some function. So if it is, then that must mean that the derivative with respect to x is equal to yz. The derivative of with respect to y must be xz, and the derivative with respect to z must be xy plus 2z. So that's their starting point, and now what I want to do is I want to use this information here to guess the function. Okay, so the way I got to here is by taking the partial derivative with respect to x, so I'm going to do that. F is xyz, and then potentially I could have had a function of y and z, because let's say this was z sine y. When I take the derivative with respect to x, this would completely vanish and I would just get this. So there might be a whole bunch of y and z stuff sitting there, and I need to account for that. So this is my first guess at f. So if I go over here, what I'm going to do, I'll start with that again. F equals xyz plus g of yz. Now what I'm going to do is I'm going to take the derivative of this with respect to y and then compare it to the original derivative with respect to y. Okay, so here we go. So if that's my first guess at f, then that implies that fy is equal to xz plus g sub y. This is the partial derivative of g with respect to y. Now this has to be equal, going back over here, this has to be equal to xz. And that's convenient because those cancel. So that tells me that g sub y is equal to 0. So now if I integrate that with respect to y, I get g. Now it needs to be a constant, but in this case, the constant that I might have is a whole function of z. I might have z cubed minus sine z, but when I take the derivative with respect to y, it all goes away, so this still holds. The derivative of this with respect to y, this would be 0. So g is some function of z. We've kind of reduced it. At first it was a function potentially of y and z. Then this analysis shows that it's really just a function of z. So far what I have is that f, my original f, is xyz plus this h of z. The last piece of information that I haven't used is over here, this f sub z. So I'm going to take the derivative with respect to z here and compare it. Fz is equal to xy plus h prime of z. And that's supposedly going to be equal to this guy over here, because that's also fz. So let's set that equal. Let's do it like this. That implies that xy plus h prime of z is equal to xy plus 2z. So that tells me that h prime of z is equal to 2z. And now I'm in a position to get the final piece that I need. I need to know what h is. H of z is, I integrate that and I get z squared plus a constant. Okay, so all told, what do I get? F is equal to x, y, z plus this h of z, which I found to be z squared plus a constant. And if I go back to my original integral that I wanted, I wanted to get this integral, and now I found that that function is the gradient of something, and I got that function there. So now all I have to do is plug in f of q minus f of p. That should have been minus there. So let's do that. F of the integral of f dot dr, that's equal to the gradient of f times dr, which is equal to f of q minus f of p. Okay, so now if I plug in q, I get 4 times 6 times 3, which is 72. Plus the z squared gives me 9. Okay, so that's the f of q minus f of p, which is going to be 0 plus 4. So that's equal to 70.